All right, 9.5 practice area of polygons. This section starts off pretty easy and then gets pretty tough. We actually got to use some trig from chapter 8 as we move down towards the bottom. So the biggest thing right out of the gate is to find the area of a regular polygon. Remember, the word regular just means that all of the sides are the same and all the angles are equal. So they're kind of what you would normally think of an octagon or hexagon or pentagon. But then you have this weird apothem. So the apothem is actually, if you go from the very center, it goes out to a wall at 90 degrees. So that's what's referred to as apothem. Be careful, because some people think that this is an apothem, okay, but it's actually not. That's what some people call a spoke or a radius of the hexagon. So remember, you're going to the wall at 90 degrees. So it says the area is 1/2 the apothem times the perimeter. So let's kind of start off with our formula and get it rolling here. So I'm going to move this up. So the area is 1/2 the apothem times the perimeter. So for this problem, the area is 1/2, the apothem is 11. Now to get the perimeter, I need to add up all the sides. And so the perimeter is what this length is all the way around. And I could add up 12.76 times, but I'm pretty much just going to multiply that together. So I'm going to go 12.7 times 6 sides and pull up my calculator here and see what shakes out. So we have 0.5. Actually, let's just kind of quit out of this. Clear it out. 0.5 times 11 times 12.7 times 6 should give us a grand total of 419.1. So 419.1 for that hexagon there. All right, doing the same thing over here for number 2. Looks like we have the area is 1/2 11, and now the perimeter is going to be a little bit different, because for this one each side is 16, but then we're timesing it by, this thing has 5 sides, so I need to times that by 5. So my perimeter here is 50 and 30, that's 80, and I got 11, and I got the 1/2. See if I can do this without the calculator. Half of 80 is 40, and 40 times 11 is 440. So 1 and 2, not too bad. Just pretty much stick it in the formula and keep on going. All right, moving down here to the next one. We have the apothem, we have a side, we should be good to go. So 1/2 apothem times perimeter is 41.6. multiplied by 3, because we have 3 sides. So 1/2 of 12, that's 6, times all this stuff, 41.6 times 3. I'm going to cheat and use a calculator here. So 6 times 41.6 times 3. Oop, something went wrong. 6 times 41.6 times 3, 748.8. All right, number 8. Looks like we got, oh, this one's a big one. Looks like 9 sides maybe. I don't know, 1, 2, 3, 4, 5, 6, 7, 8, 9 sides. All right, so we have a nonagon. So 1/2 times apothem times perimeter is 11.6 times 9 sides this time. So let's just cheat and go straight to the calculator for this one. Let me move him over a little bit. So 0.5 times 16 times 11.6 times 9 equals 835.2. All right, so far it's just plug and chug. Just putting numbers in the formula. Now for number 5, it says for the rest of the problems, you're going to need to find some angles and use trig to get the apothem or the perimeter. So this finding angles part we did earlier in chapter 9. I think it was in 9.1. And then to do the trig, we're going to have to go back to chapter 8. So we're going to have to be able to walk and chew gum on these problems here. All right, so let's see what we got going on. So looking at my formula, I'm going to just kind of write that down here. My formula is 1/2. We don't have the apothem. All right, so we're missing, I'm just going to write A right there. We're missing our apothem. But we do have the perimeter. Okay, the perimeter is just 12 times 6 sides. So really the only thing that we're missing is this A. So let's kind of go in here and let's draw ourselves an A. And don't know why that was turned out like that. And then what I'm going to do is I'm going to kind of extend this down and turn this into a triangle. All right, from here, a couple things that I could do. One way I could do this, I know this is 90 degrees because that's what an apothem is I could either go for this angle right here if I want to, or I could go for this angle right here where I want to. For this problem, I'll go after this one down here, and then the next problem I'll show you how you can go the other way. All right, so doing some scratch work here. First of all, let's figure out how much an angle is in a hexagon. Some of you might have it memorized from 9.1, but if you don't, the way that I like to do it is I like to figure out the outside angle. All right, I'm just call this Y. And I know that when you figure out all the exterior angles for any shape, the sum of all of them is 360 degrees. And since if I extend it out and kind of keep going all the way around, and each of these little guys are called Y, you're going to find out there's 6 of them. So if I divvy that up 6 ways, every outside is going to be 60 degrees. And if these form a straight line, if the outsides are 60, that means that these insides are going to be 120 all the way around. And this 120 gets broken up into 2 pieces by that radius or by that spoke. So this is going to be 60 degrees, which will give me 30 degrees. And I should be able to now figure out the apothem because they told me that every side was 12. So on this bottom, if the whole bottom is 12, this little piece right here is going to be half of that, or 6. So let me kind of it's getting kind of cluttered on my picture. Let me kind of go over here and draw the triangle that we're after. So I have A, I have 6, and then I have 60, and I have 30. And I can pretty much stand wherever I want in this one. You could actually, the fastest way would be, instead of using SOHCAHTOA, use your special right triangle rules. Remember, the smallest side is always going to be half of the largest side. And then the side across from the 60, the longer leg, is going to be the bottom radical 3. So I know the answer is going to be 6 square root of 3. I always use the special right triangle things whenever I can. If you wanted to kind of go the longer way, you could have maybe set your guy up here at 60. And since let's just pretend that we didn't know this, and let's pretend that we didn't know that. You could have set your guy up here, and you could have used tangent, and you could have said, hey, the tangent when standing on 60 degrees is opposite over adjacent, and times both sides by 6. And that will also give you that 6 radical 3. Let's just see what that is on the calculator really quick. 6 times square root of 3 is, we'll call that 10.4. All right, so we're going to call this side 10.4. So I'm going to go back to my equation here. 1/2 times 10.4 times 12 times 6 is 72. And pull back up the old calculator. And we're going to do 0.5 times 10.4 times 72. Bam. It looks like 374.4. So 374.4 is your final answer. So that one's quite a bit more involved, a little bit tricky. Move on down, we have a couple more here. We have 6 and we have 7. So this problem is a little bit different. I do have my apothem, so that looks good. But what I don't have is I don't have the perimeter. I don't have a side length to get my perimeter. So I think what I need to do in this problem is I'm going to draw my little triangle, and I need to kind of find out that little X piece. Now X is just going to represent this, and then when I find that, I'll double it to get my side. All right, so for this pentagon here, I'm going to show you another way of doing this problem. See how I broke that up into a triangle? If I kind of made this a little bit, let me kind of go into these advanced tools here and just make my pen a little bit smaller. There we go. And if I start drawing these triangles all the way around, so this might be a nice way if you forget the formula. If I start drawing my triangles all the way around, I'm going to notice for a pentagon, I have 10 triangles. All right, 10 of those. And if I look at all of these little pieces right here, they should all add up to 360 degrees because there's 360 degrees in a circle. So if I do 360 degrees divided by 10, that means that every single triangle piece should be 36 degrees. So that should be 36 degrees in there. And now I can use trigonometry to solve this one. So let me kind of do a little bit of scratch work here. I'm just going to draw the triangle that's important. So we have a triangle. We need this. We have that. And we have 36 degrees sitting in there. So how I'm going to solve this is I'm going to put my guy on the reference angle. I'm going to label my sides. This is opposite and this is adjacent. So I need to use tangent. So the tangent when standing on 36 degrees is opposite over adjacent. And if I cross multiply, I'm going to get x equals 8 times the tangent of 36. All right, so let's bust out the calculator. 8 times tan 36. I get about 5.8. All right, so we get about 5.8. Should be a 5 there. So if this little piece is 5.8, that means that the entire side is double that. So that would be 11.6. So that means every single side is 11.6. So I had to do some trig there to figure out the side length. So now we can go back to our original equation for area of a regular polygon. It's 1/2 the apothem they gave us. The perimeter, okay, remember this is our perimeter. The perimeter is 11.6 times 5 sides. So let's kind of go in here and bust this out. So 0.5 times 8 times 11.6 times 5. Bam! 232. So correct answer for this one I'm getting is 232. All right, number 7, kind of similar. This one is probably one of the hardest ones because they don't give me A and they don't give me P. So we got our work cut out for us here. Let's see what we got going on. So if I draw my own, so a little apothem right here. So there's going to be my A. And then I also need to find X. So I got a lot missing right now. Really the only thing I have in that triangle is I have the hypotenuse. So let me kind of draw this over here off to the side. So this is the triangle that we're focusing on. I do know the hypotenuse is 10. This side is X. This side is A. And I need to figure out the degrees. I don't know I'm going to kind of try to figure out this outside angle. This is an octagon, so it has 8 sides. So if I do 360 divided by 8, I get 45. 5. And then if we split that in half, 135 divided by 2, I believe is going to be 67.5. So we have a 67.5 degrees down there. So right now, this all depends on who we want to go after first. I'm going to put my guy right here. And let's go after the Apothem first. So the Apothem, to get him, it's going to be opposite. And then we have hypotenuse. So we're going to set up a little equation. And we're going to go sine, because that's opposite and hypotenuse. Sine of 67.5 is a over 10. So I times both sides by 10. And 10 sine 67.5. Let's kind of move him over. Ten times sine 67.5. Well, I put 1. 10. Kind of hard doing this calculator on a touch screen. 7.5. Boom. Let's just call it 9.2. So we know A is 9.2. So I'm going to go ahead and I'm going to put that right in here. And now to find X, I'm going to kind of play the same game. But to find X, this is the adjacent in hypotenuse. So I'm going to do cosine. So the cosine of 67.5 is adjacent over hypotenuse times both sides by 10. And let's pull that one up. 10 cos 67.5. And that is 3.8. So I have 3.8 right here. Which if I double that, because remember, 3.8 is only this little piece. So if I double 3.8, I'm going to get 7.6. So now I know that every single side is 7.6 all the way around. So I think we have what we need. We have A, we have the side. So let's kind of get after the final equation here. So the area should be 1/2 the apothem times the perimeter is 7.6 times 8 because I have 8 sides. So let's see what this shakes out to be. 0.5 times 9.2. Check that. 9.2 times 7.6 times 8. 279.68. Wow, that was a lot of work. That's like the hardest one. When you're given that radius or that spoke, that's the toughest one. All right, 2 more to go, number 8 and number 9. So it looks like we have the apothem here. So this is our A, and we need to kind of figure out the angle. And this one's kind of easy because this is a 60, 60, 60 triangle, which means each of these pieces are going to be 30, which is kind of cool because that means that this is a special right triangle. So I'm going to use my little trick on this one. So since this is 30, this is going to be the short leg. All right. The hypotenuse would be double, but we don't really need that number. And then the side opposite the 60, this side, is going to be 4 radical 3. And so if I figure out what that is, let's just kind of get the decimal for the 4 radical 3. So 4 times radical 3, boom, 6.9. So I'm going to kind of use that 6.9, but then I got to double it because 6.9 is just this piece. So when I double it, I get 13.8. So each side on here is 13.8. So final formula, 1/2 apothem times perimeter, and we have 3 sides on this one. So let's knock this out. 0.5 times 4 times 13.8 times 3 equals 82.8. And finally, number 9. I know this one's a bit long. This one looks like it's going to be kind of nasty because we have a radius here. We're missing our apothem and we're missing our side length. Now the nice thing is this thing is a hexagon. We've already kind of figured out that in a hexagon it's 60 and 120. So that kind of is nice for me because when I draw my apothem in right over here, I know that this angle is going to be 60. So it's a special right triangle. So using my special right triangle rules, I don't have to, otherwise I'm going to have to do trig twice. I don't really want to. So since this is the hypotenuse, the longest side, I cut it in half. So that's going to be 6.5. And then the apothem is going to be 6.5 radical 3. Now let's actually get a decimal for that. It's just a little bit easier to work with. So 6.5 times, what's going on here? What's up with my calculator? All right, my graphing calculator is acting kind of glitchy, so I'm going to try this little cheap one on the screen. But I'm going to do the square root of 3 and then multiply that by 6.5. And so we get about 11.25. So I'm going to kind of change this apothem over here to 11.25. So I think now we can solve it. We have 1/2 times the apothem times the perimeter, which remember if this side's 6.5, that will be another 6.5, which will give me 13 for each side. So I have 13. And then there's going to be 6 sides. So let's see if this cheap little calculator works again. Can't seem to get him to pop up. So I'm going to use my phone. So using my phone, I ended up with 438.75. All right, that homework assignment was a bear. And, you know, if you're doing this during the quarantine, it's going to be kind of tough probably to master all of these problems. But I would say that definitely the first 4 you should be able to plug and chug. And then hopefully if I give you the apothem, you could figure it out and work from there. These ones with the radius, you know, like number 9 and let me see, number 9, number 7, you know, those are kind of rough. And I really wouldn't expect you to master those without being formally sitting in class getting some more help from me.